Okay, we're going to be taking a look at what appear to be some really challenging integrals that we're going to be working with, but I'm going to point out to you that they're actually not as difficult as they look. Okay, so what I want to point out here, and I'm going to zoom in here for a second, so you can see real quickly. Here we go. We've got an integral, and I moved this out of the way because I want you to see how this stuff kind of corresponds. If you see here, I've got x, all right, and that corresponds with this x, okay? And then I've got this 5 right there, and that corresponds with this ax. Actually, no, that's incorrect. The 5 corresponds with this b right there, all right? And then I've got the 6x, and the 6x here corresponds with this ax. So if you see, the form matches, all right, the form matches, if you will. So what we're going to do is we're going to use what's called a table of integrals, and we're going to look at a series of examples here on the table of integrals. So what you can do is you can look online, on your favorite search engine, and find yourself a brief table of integrals. Many textbooks have them, in the front and the back. Sometimes they're card inserts that you can rip out. But somewhere in your book, somewhere online, you'll find a table of integrals, and they're actually really nice because they make tough and challenging integrations a lot easier. All right, they're basically just formulas that you're going to apply. So we're going to look at this one, and it's called 29a. Every book is different, but I'm going to pluck out the information that I need. In this case, the ax, I said, corresponds to 6x. So in this case, a equals 6. The b equals 5. Well, that's enough information to go ahead and evaluate this integral. All right, so what I'm going to do, now that I've plucked out the information, my integral looks like this right here. All right, my integral looks like this. Sorry about that. My integral looks like this right there. Okay, so that's what we're going to do, is we're going to use that form to help us. So I'm going to start off by saying 1 over the square root of b, which is 5, then the natural log, okay, of the square root of ax plus b, so in this case 6x plus 5, minus the square root of 5 over the square root of ax plus b, which again is 6x plus 5, minus, in this case, plus the square root of 5, and then we close our absolute value there for the natural log, plus c, our constant of integration. So there's really nothing to it in this case. All right, there's really nothing to it. We've managed to figure this out. Just follow the formula. So let's go ahead and take a look at another example. Okay, so now in this second example, we're again using the table of integrals, and we're going to use this one right here, number 43. So what we're going to do is again pluck out the information that we need to know. Well, if you notice on this integral number 43, all I see here is this a. All right, that's all I see here. So what we're going to do is we're going to pluck out the a from our problem here, and so this right here represents our a squared, so that means that our a is just the square root of that, which is 2. Square root of 4 is 2. So now what I'm going to do is I'm ready to integrate. So I'm going to write x over, and I'm going to say 2 times 2 squared times, and then it's just going to be 4 minus x squared, because that's a squared minus x squared. All right, so we have that, plus 1 over 4 times 2 to the third power times the natural log of the absolute value of x plus 2 over x minus 2 plus c, your constant of integration. And so then all we have left here to do is kind of clean this up in the way that it looks. So we're going to end up with x over, and then we have 8, because 2 squared is 4 times 2 is 8. 8 times 4 minus x squared plus, and then 2 cubed is 8, and then 8 times 4 is 32, so 1 out of 32, natural log of the absolute value of x plus 2 over x minus 2 plus c, our constant of integration. So really nothing to it. I mean, it's really nice, okay? It's really nice and really simple to do these with the table of integrals. So let's go ahead and take a look at another example. Okay, in this next example, we're going to be looking at integral table number 78, item number 78 from the table. And so let's see what we can pluck out. We've got A, B, and C here. A, B, C. All right, so let's see. Let me color code this for you. Here's A. A is the X component, so that's this 2. B is this constant here, so that's B right there. And C is the coefficient of the sign, in this case 13. All right, so we've got everything down that we need. A is 2, B is 5, and C is 13. And it's got this special note here that B squared should be less than C squared, and that checks off. So we're good to go. All right, we are good to go. So now all we do is plug in the information that we need to know. And that is that -1 over A, which is 2, times the square root of C squared minus B squared. So 13 squared minus 5 squared. All right. And then we multiply that by the natural log of the absolute value of C, which is 13, plus B, which is 5, sine of AX, so 2x, plus the square root of C squared minus B squared. So that's again 13 squared minus 5 squared, times the cosine of AX, which is 2x in this case, over B, which was 5, plus C, which is 13, sine of AX, which is 2x. And then we close our absolute value. We add our constant of integration C. The only thing left to do here is to clean this up in the way that it looks. So we're going to go ahead and do that. We have a -1 over. Now this right here is 169 minus 25, which is 144. And the square root of 144 is 12. So 2 times 12 is 24. So -1 out of 24 right there. All right, we've got that part down. We've got the natural log of the absolute value. We've got 13 plus 5 sine 2x. We figured out that that whole square root thing just works out to be 12. So plus 12 cosine 2x over 5 plus 13 sine 2x, close the absolute value, plus our constant of integration, and we are done with this problem. We've integrated it. All right, so really nothing to it. Like I said, we're just following the table of integrals, and let's take a look at one last example. All right, so for this integral here, we're going to be referencing table value number 69a in this particular table. So again, you may find a different set of tables, but otherwise these should be general formulas that you'll find on that table of integrals that you might find online or somewhere in a book. All right, so let's go ahead and take a look at this one. This is one for a sine of AX cosine BX, and we're going to kind of match everything up here. So the AX corresponds to this 4x here in our sine function, and this BX corresponds to this 2x here in our cosine function. So let's go ahead and jot that down. We know that A then is going to be, let's see here, A is going to be 4, and B is going to be 2. All right, A equals 4, B equals 2. And there's really nothing more to do with this other than plug in the numbers. So we have a negative cosine A plus B, so 4 plus 2, which is 6x. All right, over, let's see, 2 times A plus B. All right, 2 times A plus B, so 4 plus 2 again is 6, so 2 times 6. And then minus the cosine of A minus B, which is going to be 4 minus 2, which is 2, so 2x, over 2 times A minus B, so 4 minus 2 again is 2, plus C, your constant of integration. All right, we've got that there, nothing really to it. We can clean it up a little bit more. We can say negative cosine of 6x over 12 minus the cosine of 2x over 4 plus C, our constant of integration, and we are done. So again, we're using a table of integrals to make our life and our job in calculus a lot easier. So find yourself a table of integrals online somewhere and get to integrating. As always, I hope this video was helpful, and remember, like and subscribe.